Today we're going to be learning to solve equations 2.1 and 2.2. Okay, 2.1 is solving equations where you have to do an addition or subtraction to both sides. 2.1 is labeled solving equations, the addition principle. Okay, an equation is where you have like 2x equals 6, something like that, or x plus 7 equals 12. An equation has an equals in it, and it has a variable, so you have to solve for the variable. Okay, we're not doing these till we get to 2.2. If it has a plus, that's the kind we're doing in 2.1. Okay, if you do something to one side of an equation, you have to do it to the other side of the equation. So if we want to find out what this was before we added 7 to it, we need to subtract that 7 to find out what x was before. So we need to do that to both sides. If we subtract 7 from this side, we subtract 7 from the other side. And that leaves just the x on this side. 12 minus 7 is 5. Okay, and you can always check your answers by plugging the x back into your original equation. You put the 5 where the x was. Have 5 plus 7 equals 12. Okay, it's called equivalent equations when both sides are equal. So you add this up, you have 12 equals 12. That's equal, so it checks out. Okay, so if there's a plus on here, you're going to subtract it. If there's a subtraction, if you have like a minus 6 equals 15. If there's a subtraction, you're going to add. You have to do the opposite of what was done to your variable. Look at the variable side. There's a minus 6. So before you subtracted 6, what was it? We'll add that 6 back, and you'll see what it was. The a is what's left on this side. We bring our equals down. 15 plus 6 is 21. So it was 21 before you subtracted 6. Let's plug that in to see if it works. Put the 21 here, minus 6 equals 15. 21 minus 6 is 15, so it checks out. Okay, let's do one with the variable on the other side of the equation. You're going to do the same thing. Let's say we have a negative 3 equals y minus 2. Okay, look first where the variable is. What are we going to do? It's subtracted, so what are we going to do to both sides? Add what?
Add 2.
Add 2 to both sides. Okay, that leaves the y. Negative 3 plus 2 is what? Negative 1. And then you can plug that back in. That's our answer. Now let's put our original equation, and where the y was, right here where the y was, we'll put our solution. Our solution was negative 1. Negative 3 equals negative 1 minus 2. Negative 1 minus 2 is negative 3. It checks out. Okay, let's do another one. Let's do one with fractions. Let's say x minus 1/3 equals 1/2. Okay, what are we going to do to both sides? Add 1/3. Cross this one out, you have the x alone. 1/2 plus 1/3. And what is that? What do you need to do?
Find the
Common denominator, which is?
6.
Okay. 3 times 2 is 6. So this one is a 2. 2 times 3 is 6. So times 3 on the top, so you have 3 on top. 3 6 plus 2 6 is 5 6. And you can plug that back in, and you can find out it's right. Plug it back into there. 5 6 minus 1/3 equals 1/2. Let's get a common denominator, which is 6, right? This is 2 times 3 is 6. 3 times 2 is 6. So this one's 2, this one is 3. 5 6 minus 2 6 is 3 6. That's right. Checks out. Okay, you're also going to have some where you have the number in front of your variable. So let's do one like that. Let's say we have negative 1/2 plus x equals 1/6. Okay. Look at the side where the variable is. How are we going to make it where it's just x? What can we put on that side to make it where this part will go away?
Add 1/2.
Add 1/2. This is the same as subtract 1/2. So you're going to add 1/2. You want to make this 0. So if that's a negative, you will add. If it was a positive, you would have subtracted. So we're going to add 1/2 to both sides. That brings our x down, bring our equal down. What did we do? I didn't write the plus part. You need to always write your sign so you'll know what you're doing. Okay, we need the common denominator. The top one is okay, right? 6 and 1. This is times 3. So 1 times 3 is 3. 1/6 plus 3/6 is 4/3, which is 2/3, right? Make sure you reduce it. Okay, let's do another one more. Oh, let's do some division ones too. Yeah, let's do some division ones too. Let's do one more where it's just like a number in front of it. Okay. Even though it's in front, think of it as the same as adding 3. Okay, this is a positive 3, so what are we going to do? Subtract 3. Right. 17 minus 3? 14. 3 plus 14 is 17, so that would check out. Okay, let's do some where we're dividing now. Like the first one here that I showed you, this equation, 2x minus 6. 2x minus 6, okay, is equal, no, 2x equals 6, I'm sorry. That's an equation. Minus 6 is an equation. Okay, what was done to our variable? It was multiplied by 2, right? We were doing the opposite of, like if it was subtracted, we were adding. This was multiplied. So what do you think we'll be doing? The opposite of multiply is divide. It was multiplied by 2, so you're going to divide by 2. So x equals 6 divided by 2 is 3. Okay, let's say, what if it had a negative 3? Y equals 9. This is multiplied.
-3.
Divide by negative 3. Don't think of this as subtracting because this is multiplied here. You divide by the exact same thing that was multiplied. Okay? So you have y equals 9 divided by -3 is -3. So -3 times -3 is +9. So if you plugged it in here, put the -3 here, it would be equal. Okay. Is there any of 2.1? Look on page 144, 145. Is there any of those that you'd have questions about that you want me to cover? There is some that show like a little check thing under it. Like number 16 says t plus 10 equals 44. And then it has a little check thing under it. So first you solve it. Looking at that, you're going to subtract 10. T equals 44 minus 10 is 34, right? Okay, the little check thing is what I was doing when I was plugging it back in, where it says check right here. It has t plus 10 equals 44, and it has a little question mark there. So what it's wanting you to do is just to plug this in. 34 plus 10, 44. So you get 44 is 44, and you see that it checks. That's all it's wanting you to do there on that row where it has the little check, is it's wanting you to plug it back in and check it. Okay, no questions on any of those on 2.1? Okay, we'll go to 2.2. This is multiplication like the 2x plus equals 6 one, where we had 2x equals 6 and we divided by 2. That's like we're doing on number 2.2. Okay? One's like this. So you say you had 5x equals 70. What are you going to do with that? Divide by 5. Right. X equals, 5 goes 1 time, that leaves 20 is 4. Okay? So 5 times 14. 5 times 4 is 20, 5, 6, 7. 14 times 5 is 70. Okay, let's say you have a fraction in front of the x. Let's say you have 2/3 x equals 15. Okay, you're going to divide both sides by what was multiplied, right? You're going to divide by 2/3, divide by 2/3. Okay, when you divide by a fraction, remember when you divide by a fraction, what you have to do here?
Pretty good decimal.
We could multiply by the reciprocal. So if we're dividing by 2/3, we put the 15 here and multiply by the reciprocal. This one would make a crazy decimal. If you did it as a decimal, it would be 0.66 repeating. This gives you the exact number. So we're multiplying by the reciprocal, which is 3/2. Okay? X equals 15 times 3/2. That won't do any canceling. So we just do 15 times 3, 45. 1 times 2 is 2. Okay. If you have an improper fraction, do you remember how to change it to a mixed number? Divide. The top number goes under the division, okay? It's not always the big or whatever. Well, it will be the big in an improper, but it's always the top number that you put under the division when there's a fraction here. 45 divided by 2. 2 times 2 is 4. Bring your 5 down. 2 into 5. 2 more times. 2 times 2 is 4. 1 left over. So you have 1/2. 22.5. Okay. Let's say you have a negative. Let's say we have negative x equals 52. Okay, this is like a -1. Negative x means -1 times x. So if you're multiplying -1 times x, you're going to divide by -1. 52 divided by -1, just -52. Right. Let's do a negative with a fraction. Let's say we have 3/8 equals -5/4 x. Okay, we were working on this side, but what you do is you look at the side where the variable is, okay? You don't always work from the left or always from the right. You look where the variable is. What was done to that variable? It was multiplied, right? It was multiplied by a -5/4. You need to divide by that same number. But to make it shorter, instead of putting over on both sides, if we're dividing by this number, we're multiplying by the reciprocal, right? So to save space, why don't we multiply both sides by the reciprocal? Putting the 4 on top and the 5 on bottom. You have to keep the sign. When you do reciprocals, you keep the sign. See, negative times negative will make it positive. The reciprocal keeps the sign. So keep the sign and flip it over. Put that on both sides. So now you're going to multiply this. This one will cancel out, right? It'll be a positive 20/20, which is 1. 1 times x is just x. So they pretty much cancel out. Make 1. Okay, negative times positive will be negative, right? You want to do anything before we start multiplying here?
We're losing the 8.
Yeah, we want to cancel, divide by 4. And then we have on top, 1 times 3 is 3. 5 times 2 is 10. So there's your answer right there. Let's do another one of those, huh? Okay. Let's do 15 equals -1/5 x. What are we going to multiply by?
Maybe I change it to 5/1.
Right, by the reciprocal. We're going to multiply by the reciprocal, which is negative, and then 5 on top, 1 on bottom. -5/1 is the same as -5, right? So we could put -5/1, or we could just put -5. You could put over 1, but you don't really have to have that.
Wouldn't that be -1?
Which part? This one?
1 times 5 is 5. 5 times 5, it's 5/5, so.
Yeah, this, on this side, we're going to have positive 5/5, which is positive 1, yeah. Positive 1x, what is 1x?
X.
Same as x. That's why we multiply by the reciprocal. We want this to be 1. The other side's where our answer is going to be. So -5 times 15, we know it's going to be negative, so we multiply it by 5.
73.
75. So there's our answer. Negative 1/5 times negative 75 should come out to 15. Negative 1/5, and if we put the 75, negative 75 where the x is, see if that comes out. Negative times negative is positive. We'll have 75 over 5. Is that equal to 15? 75 divided by 5 goes 1 time and then 5 times. So that's right. You don't have to check every one of them, but if you do check every one, then you already know you're going to have 100%. The good thing about this homework is you can get 100% just by checking all your answers. Okay, what about decimals? Let's say you have 3.2 y equals to 6.4. Same principle. What did you do to it? You multiplied, right? Opposite of multiply is divide. Multiplied by this, so you're going to divide by this. Divide by 3.2. And you get 2. There's your answer. And, oh, let's do one where there's just a letter on top. Where you have like t over 6 equals 48. What divided by 6 is 48? Don't say 8, because 8 divided by 6 is not 48. 8 times 6 is 48. Okay, it's not going to be something that just comes to your brain. This is divided by 6, so what do you think we'll be doing?
Multiply by 6.
Yeah, it was divided by 6, so you're going to multiply by 6. Those two cancel out. They're just 1 t, so it's just t. 48 times 6. 6 times 8, 48. 24, 25, 26, 27, 28. 288 divided by 6 is 48. Let's do it where it has a negative also. Let's say negative y over 5 equals 20. And it's not 4 or negative 4, okay? It's not multiplication here. Okay. This one you can do in 1 step or 2 steps. If you want to just see how it's divided by 5, if you want to multiply by 5 first, you're still going to have negative y. So if you multiply by 5, then you're going to have to do another step and divide by negative 1. Let me show you that way, and then I'll show you the quicker way. If you multiply by 5, then you'll have negative y, because this part will go away, equals 100. Then you'll have to divide by negative 1. So you have y equals negative 100. Okay, let's look at it another way. Negative y over 5 equals 100. Oops, 20. My pen's running out. Okay, here's another one. Okay, negative y over 5 equals 20. Okay, look at this as like negative 1/5 times the y. Okay? And go, okay, well, I'm going to multiply by the reciprocal, which is the same sign. Same sign and flip it over. Multiply by the reciprocal. See, negative times negative is positive. 5 over 5 is 1y. 20 times negative 5 is negative 100. Okay? So you could do it either way. You could do it where you multiply by 5, and and then you do the -1, then divide by -1, or you can multiply by the reciprocal, making this into a fraction, where you do the reciprocal of it. Okay. Let's do one more fraction one, and then if you have any questions, we'll do more. Let's do, if we have like -3/8x equals -15 over 16. What are we going to do with this one?
Multiply by a verb.
By the reciprocal, right? Multiply by the reciprocal, which means you keep the sign, flip it over. Got to do it on both sides. If you do it to one side, do it on the other. So this is +1, positive 24. So that's 1x. Negative times negative. Okay, when you're multiplying, do we need to get a common denominator? No. Just adding and subtracting. So here we're multiplying, so we could do some division first if we'd like. I'd rather divide than do 15 times 8 and 16 times 3. So let's divide by 8 here. Divide by 8 is 1, divide by 8 is 2. The 15 and 3 we can divide also. Divide by 3. Divide by 3, divide by 3. So that's all we can do. We have a 5 on top and a 2 on bottom. Negative times negative is positive. So we have a +5/2 is our answer. And you can change that into 2.5. In the back of the book, you'll find a lot of answers that they just left as improper. And if, most likely if it had an improper fraction, I'll go ahead and put or this number so you can get in the habit of changing it. Because it's really not good to leave them improper. Is there any questions when you look at the problems on 2.2? Is there any of them you want to do together?